So we are on line measures, and our vocabulary here, the first one is line segments. And line segments can be measured because they have endpoints. And the length of a line segment always includes a unit of measure, for example, inches or meters. An example here would be point A ends at point B. And so here's a line segment. Notice it does not have arrows going off on both directions. And we could say that's like 5 inches is the length of that distance there. Okay. And so how do you specify a line segment? You say AB with a line over it, no arrows on the ends. The next vocabulary word are segments that have the same measure, and those are congruent segments. So congruent segments. And so we can state it like this. We can say A and B, then we can say C and D. Right. So how do we know if two segments are congruent? Well, it's because their measures are the same. So if we're over here and I say 1 meter, and over here the length of this line segment is also 1 meter, and then I could say that line segment A and B, AB and CD are congruent, not because their angles are the same, or not because they're any other characteristic other than their measurements, other than their length. So I'm going to come over here and say AB, or line segment AB, is congruent with line segment CD. Okay. And so here is the idea that there's always a point between other points. This the idea here is called betweenness of points. Okay. And so what does this mean? Well, if I have a point A over here and a point C over there, and they both lie on the same line, then I can say that B is in between A and C, right? Betweenness of points. All right, so let's go ahead and move on down. And a part of a line between two endpoints is called a line segment. Ooh, line segment. And the lengths of MN and line segment MN and line segment RS are written as MN without the line and RS without the line. Right? So if we're talking about the length, if we're talking about the measures, we do not write the line above the points. Okay? All measurements are approximate, dependent upon the smallest unit of measure available on the measuring instrument. So here we have an example: find the length of MN. And what we do here is we can see that the ruler's in centimeters, so we count the number of centimeters, right? So we have 3 centimeters. So I'm going to say MN, the measure of MN, the length of MN, is equal to 3 centimeters, right? But we still have some centimeters left, so what I'm going to do is I'm going to count the number of fractions of a centimeter. So it's 1, 2, 3, 4. So it puts a 4, goes in the numerator, and then I count all of the fractions of the centimeter and put that in the denominator. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put a 10 in the denominator, and you can see we can reduce that fraction by dividing by the greatest common factor of 2. So if I divide 4 by 2, I get 2, and I divide 10 by 2, I get 5. So my answer here is 3 2/5 centimeters. Right, so the length of MN is equal to 3 2/5 centimeters. All right, so we're looking at this one over here, the length of RS, and so I'm going to say RS without the line above it is equal to, and then we got 1 inch, so I'm going to say 1, and then the number of fractions of an inch go in the numerator, so it's 1, 2, 3 goes in the numerator, and then 1, 2, 3, 4, the total number of fractions of an inch go in the denominator, and I could give it the units inch, and that's my answer for the length of RS. Why don't we stop there and we'll finish the rest in the next video.